Hello and welcome to SudoKanard. Once again, a video in English about solving some great Kakuro puzzle taken from the excellent website Grandmaster Puzzles by one of the Grandmaster puzzle creators, Fikes, and that's a non-consecutive Kakuro. I've never done one of those, so I think it will be fun. So here's the puzzle. The usual Kakuro rules apply, meaning that every time you have a sequence of empty cells, the digits must be all different, and their sum is here in the margin. So 11 is the sum of these two digits, 7 is the sum of these three digits. And the additional rule is that two consecutive cells, two adjacent cells, meaning that they share an edge, cannot contain consecutive digits. Well, for 10, it couldn't anyway, because two consecutive digits would have an odd sum, and 10 is even. But here, for example, 11 can't be 5 plus 6. Well, you couldn't put a 5 or a 6 anyway because of this 7, but that's the idea. On the website Grandmaster Puzzles, you have timings of reference. Well, a solve of 6 minutes and a half would make you a Grandmaster. 10 minutes is the timing of a master, and double that, 20 minutes is an expert timing. Well, I'm targeting this kind of timing, but usually it takes me more time than that. So let's start. And this 4 can only be 1 plus 2 anyway, and 1 plus 3 I mean. Oh, this 5, it can't be 2 plus 3 because of this non-consecutive root, so it has to be 1 and 4. This is nice because 7 can usually be 1 plus 6 or 2 plus 5 or 3 plus 4, but we can rule out this 2 plus 4. And now the bigger digit must be here because 1 and 2 are not suitable for a 13 sum, but it can't be 6 because it would need a 7 here and it would make consecutive digits. So that's a 5, 2 and an 8 here. Now we need 11 more, and it can't be 6 plus 5, but there are several possibilities. So I look at this 15, 7 plus 8 is not possible, so it has to be 9 plus 6. And I can't put the 6 in here because it would require a 5, so that's a 9, that's a 6, and that's a 2. This 7 can only be done with 1, 2, and 4. 1 and 2 can't be in adjacent cells, so 4 must be between them. And that's a 7. And we have 1 or 2 in those cells. The same here with this 7. 4 here, 1 and 2 in some order. This 4 is 1 and 3, but 3 can't be here because it would require a 4. So that's a 1, that's a 3, that's a 6. We need another 8, and obviously the digits won't be consecutive, whatever digits we put in here. What next? This 5 clue must be 1 and 4 in some order. This 7 again, there's a 4 in here, 1 and 2. There must be something about this. The decompositions of 9 are 1, 2, 6, 1, 3, 5, and 2, 3, 4. 2, 3, 4 is impossible because whatever order you choose, you have two consecutive digits next to each other. Well, 3 will be next to some digit and they'll be consecutive. So this one is impossible. 1, 3, 5 is all right with any way of dispatching the digits, but 1, 2, 6 would need to put the 6 in the middle, but we don't know more than that. Oh, this 23. 23 can only be made with 6, 8, and 9, and now 6 must be in the middle. And now I can't put a 9 because I would need 1 and 2, and they would be consecutive and adjacent. I'm not sure I pronounce adjacent correctly, but I just hope you understand what I say. Now we need a 1 and a 3, and only 3 is big enough for this 11 clue. That's an 8, that's a 1. We now need another 15. It can't be 7 plus 8 because they are consecutive, so they have to be 6 and 9. And we can't put the 9 next to the 8, so that's 6 and 9. I really enjoy this special rule. I wonder if something can be done here. It has very little interaction with the outside, so perhaps it's to be resolved right now, but I can't see how. Let's wait till we have a digit here. This 11 is really restricted because the only decomposition is 1, 2, 3, and 5. 2 can't be next to 1 and 3, so it has to be next. It must have 5 as the only neighbor, so it will be 2, 5, and then 1 and 3, or 3 and 1. This way or this way. Not sure how. Oh, so this is 1 or 2 or 3. But I'm thinking it can't be a 2 because if I put a 2 in here, then the only way of completing to 8 will be 5 and 1. But 5 can't be used in a 10 clue. It would require another 5. So 2 is here, and this is 5. And these are 1 and 3. Now this 2 resolves this 1-2 pair. Now I was about to say something. Okay, the only two decompositions of 10 in 3 different digits involving a 2 are 2, 1, 7, 2, 3, and 5. But now, can we put 1 and 7? But 7 can't go there next to itself, and 1 can't go next to the 2. So this decomposition is impossible. It has to be this one, and 3 can't be next to the 2. So that's 3 and 5 this way. Now for this 20 clue we need 17 more, which is 8 plus 9, but 8 can't go next to the 7. So this is an 8, this is a 9. Now let's have a look at this because now it has to be resolved. Now we know there are 2 decompositions of 8, which are 1, 2, 5, 1, 3, 4. Now 1 to 5 is impossible because it would require a 5 as part of a 10 clue, and that's not possible. So it has to be 1, 3, 4. 3 and 4 can't be next to each other, so 1 must be in the middle. So 1 is here next to the 9, and now this must be the 3, this must be the 1, and 4 and 6, and everything's well. It goes according to the non-consecutive rule. Now let's have a look at this 17. We need another 12. 12 will be either with 4 and 8 or 3 and 9, but neither 4 nor 8 fits this cell because 8 would repeat and 4 would be consecutive. So they have to be 3 and 9, and 9 can't go next to the 8. So this is 3 and 9 this way. Oh, and this cell is much more restricted than it seems. The regular Kakuro reasoning would be it can't be a 2, a 6, or a 9, but now it can't be consecutive with 2, 6, or 9. So it rules out 1, 2, 3, 5, 6, and 7, 8, and 9, and only 4 remains. Well, what can we do with this? If this was an 8, now we would need 16 more, which would be with 7 and 9, but 7 and 9 are both forbidden in this cell because they would be consecutive with 8. So this must be a 3, this must be a 1, this is a 4, this is a 1. Now we need 14. 14 will be with either 5 or 9, 5 and 9, or 6 and 8. 8 and 9 are ruled out from this cell, but 5 and 6 are both possible. Well, they look possible at this time of the solve. What can we do next? What happens if I put a 1 in here? How would I decompose this 14? 1, 6, and 7 is not possible because 6 and 7 would be consecutive and adjacent. Now 1, 5 and 8, why not? 1, 4 and 9, no. 1, 4 and 9 wouldn't fit because 4 would be next to the 5 and 9 would repeat. So 1, 5 and 8 looks possible. What about the 2? We need another 12. Well, 5 plus 7 wouldn't be possible. 2, 4, and 8. Well, 4 couldn't go next to the 3 nor next to the 5. So, but what about 2, 3, and 9? Well, 3 could go there and 9 could go there. So we have two possibilities. 1, 5, and 8, or 2, 9, and 3. So we have to look further to disambiguate. Oh, where do we look next? This is interesting because 8 needs 12 more. 9 needs 11 more. Let's look at the options. 9 would need 1, 2, 3, and 5. 8 would need either 1, 2, 3, and 6, or 1, 2, 4, and 5. So there must be a 1 and a 2 in any case. And 1 and 2 are forbidden for both those cells. So 1 and 2 must be in the outer cells. And now it can't be 4 and 5 in the middle because they would be next to each other. Let's forget about this. There must be a 3, and 3 can't go next to the 4, so 3 has to go there, ruling out this 2. So this is a 1. And now this can't be a 5 next to the 4, so it has to be a 6. And now this is an 8, and this is a 6. Nice. What about this 14 clue? We need another 8. It can't be 6 plus 2 because 6 would repeat. So it must be 1 and 6 or 3 and 7. No, 1 and 5. No, 1 and 7 or 3 and 5. Well, neither 1 or 3 can go there. So we have two possibilities for the time being. And we must look somewhere else. Oh, this 18. Now there's some restrictions. The remaining 9 could be 8 and 1. So 8 here and 1. No, 1 couldn't go there because it would either repeat the 1 or be next to the 2. So 8 and 9 is ruled out. Could it be 7 and 2? Well, 2 couldn't go here, couldn't go there. So 7 and 2 is impossible. Now 3 and 6 or 5 and 4. 5 and 4 would be consecutive next to each other. So it has to be 3 and 6. And 3 can't go next to the 4. So 3 is here, 6 is here. And 3 rules out this 2. This one. Now we need another 12. Oh yes, it was the possibility on the right hand side. This is it. Now we need another 14. 6 and 8 or 5 and 9. 6 and 8 or 5 and 9, and it would be in this order because of this 9 and this 6. Now, what can go here? It can't be any of those digits, and it can't be 5 or 8. So only 2 and 7 remain. Well, 7 would be incompatible with the 6, but both are compatible with the 5, and 2 is compatible with both. So only this 11 clue shall disambiguate. So we need another 8, and it can't be with 3 and 5, it would repeat the 3. It can't be 2 plus 6 because 2 would be next to the 3, or 6 would be next to the 6. So it has to be 1 and 7 can't go here. So that's a 1, that's a 7. So this is not a 7, this is not a 6, and that's a 9. Okay, now all this eastern half is resolved now. And is fully solved, I think. That's a better way to put it. And What next? Let's recap the possibilities for the 9. It can't be 2, 3, and 4. So it has to be 1, 3, and 5, or 1, 2, and 6. But now only 5 or 6 can go next to the 2. And the other digits must be 1 and 3 or 1 and 2, but 1 and 2 is not possible. So that's a 5. And now 1 and 3 can be in any order until we disambiguate. What about this 13 clear? We need another 11. It can't be, well, some of them may be ruled out very quickly. 5 and 6 would be consecutive. 3 or 9, 3 and 2 and 9 would repeat the 2. 3 couldn't be next to the 2. 8 would be next to the 8. So that's 4 and 7, and because of this 8, it's 4 here and 7 there. And now this 7 needs another 7, which is 1, 2, and 4. So this is a 1. 2 can't go next to the 1, and that's a 4 in the middle. Now this is a 1, this is a 2. So this have to be 1 and 6. 1 can't go next to the 2, so 1 is here. Now this is a 3, this is a 5. We need here another 22, which is either 9, 8, and 5, or 9, 6, and 7. This couldn't be 8 or 5, but this could be a 9. It could be 6 or 7. Many possibilities. I think I have a look at this 17 clue first. We need another 13. 6, 7 is not possible. 5 plus 8. Well, 4 and 9 is not possible because it would repeat the 4. So it has to be 5 and 8, and in this order. And now, so we can't put an 8 or a 5, nor a 9. So it can't be this. It has to be 9, 6, and 7. 9 can't go here because it would put 6 and 7 next to each other. 9 can't go next to the 8, so 9 is here. That's a 1. And 6 and 7 are in this order because 7 can't be next to the 8. Now, only this small portion remains. We need another 13. So it can't be 6 and 7. Now, here we can't put a 4 next to the 3. We can't put a 9 next to the 9, so it has to be 5 and 8. 5 here, 8 there, because 8 can't go next to the 9. Here, it can't be 4, 6, 8. It can't be 1, 3, 5, 7, 9, so it can only be a 2. Now this. What can we do? I think some brute force is required there. Let's try a 1 here. We need another 15. So could it be 9 and 6? It would then be a 2 here. What can we put in here? So it can be a 1, can't be 3, 4, 5. Can be a 7. Oh no, it can't be a 7. So 8, it can only be a 1. I think that's the solution. Well, let's rule out all other options. So what if I try 7 and 8? 7 here would repeat the 4. 8 would put a 3 next to the 4, so that's not possible. Now let's try with 4. Well, let's try with 4 here. And we should get an impossibility. We need another 12. It could be, oh, and 12 would need a 3 or a 5 next to the 4. So that's not brute force. That's as subtle as can be. So no, putting a 4 here is ruled out very quickly because 4 would be next to a 3 or a 5. So it has to be a 1. And we just show why the only possibility is this. And now this non-consecutive Kakuro is solved. And I say it was a very fun experience. Well, every Kakuro I've showcased on the channel was really a great pleasure. So thanks to all these great puzzle setters, Grand Fikes, SudoKanard, Freddy Hunt, and I'm afraid I forgot someone, so all apologies. Thanks for watching this video and see you very soon on this very French English speaking channel SudoKanard.